topic is light, and our points we have to discuss today. This one is basically depends on spherical mirror. Spherical mirror. Spherical mirror. Spherical mirror is we have two types of mirror. Two types of spherical mirror. So concave and convex. Concave and convex mirror. So spherical mirror means either concave mirror or convex mirror. But if we discuss about the mirror, so we have three types of mirrors. So if I say something about mirror, so mirror three types. One, we have to add another one, plane. We have to add another one, plane mirror. Plane mirror. Okay, plane mirror. So spherical mirror, we will discuss about the ray diagram. We'll discuss about the ray diagram of concave, convex, concave and convex. Plane mirror part today I will not explain the plane mirror. So concave, ray diagrams for concave, ray diagrams for convex mirror, and the mirror formula Today I will complete the concave part, derivation of concave. So first, spherical mirror, so concave and convex and plane mirror. In case of concave mirror, we have total 6 ray diagrams. And in case of convex mirror, we have 2 ray diagrams. In case of concave, 6. In case of convex, 2. And for plane mirror, 2 ray diagrams are enough. One for point source, another for extended source. Okay, so plane mirror, one for point object, point source or point object, and another for extended object. So in case of plane mirror, one for point object, another for extended object. In case of concave, total 6 ray diagrams. In case of convex, we have total 2 ray diagrams. So what is the concept? What is image? Okay, the image is what? It is a replica of the object. Now, what is the basic concept behind the mirror? So maybe we can consider like this. Suppose, okay, imagine that maybe let me take one copy at first. Okay. Suppose consider this one is consider. We can explain this topic like this. Somehow, maybe intentionally or accidentally they found what. Suppose that time, clear? Okay, mirrorটা কিভাবে ওরা মানে মিররের কনসেপ্টটা কিভাবে আসলো, রে ডায়াগ্রামস কেন আমরা পড়ব? তো concept is that time we can conclude like this. For example, say this is what one transparent material, and normally transparent material means it is a glass. তো প্লেন গ্লাস, তো ওই সময় প্লেন কাঁচ হতে পারে, এরকম কনসেপ্ট ছিল যে প্লেন কাঁচ, দ্যাট ইজ ট্রান্সপারেন্ট, প্লেন গ্লাস sheet. Somehow when one opaque object, when an opaque object is placed behind this transparent material. Opaque object means what? For example, consider this one is transparent sheet, and somehow somehow one opaque object came in front behind this transparent sheet. So that time they observe that they can see the object behind them. For example, this is the transparent sheet. আর কিছু ভাবে opaque অবজেক্টের পিছনে এসে গেছে. For example, that time you have glass, normal glass, that is glass made of glass. Okay, জল খাওয়ার glass, that is made of glass. Or maybe bottle, বোতল made of glass. আর কোনোভাবে ওর পেছনে ওপেক অবজেক্ট থাকাতে সেই সময় অবজার্ভ করা গেছে কি, বা কেউ হয়তো সেই সময় অবজার্ভ করেছে যে আমাদের ব্যাক সাইডে পেছনে যে ইমেজ অবজেক্টগুলো আছে তার ইমেজ ওখানে ফর্ম করে, তো প্লেন অবজেক্ট। আচ্ছা, মেবি অ্যাক্সিডেন্টালি অর ইন্টেনশনালি দে বেন্ড দিস শিট outward direction or inward direction and they observe the types of image. Okay, so when this is plain sheet, then the properties of image or characteristics of image are different. When it is bent outward direction, it is different. When it is bent inward direction, it is different. So when it is plane, normally plane, so this is the plane mirror, and normally this is the diagram for plane mirror. Concave mirror, concave is, this is the shape for concave mirror. This is concave mirror. This is concave mirror. Otherwise, a concave mirror, we can draw concave mirror like this also, no problem. We can draw concave mirror like this also. But in general case, we have to use this notation. Okay, just don't draw like this. So it is not the concave mirror. This is wrong. Okay. So this is the concave mirror. This one is concave mirror. So either you can draw this or this one. It is concave mirror. Okay, concave mirror. Next one, convex. Convex means this type of mirror. So this one, it is what? Convex mirror. This is convex mirror. There is plane mirror. This is the diagram for plane mirror. It is the diagram. So let me erase this part. So we have to use this one for concave mirror and this notation for convex mirror. Sir, which is the reflecting surface? This is the reflecting surface, and this one, this dot part, it is the coated. Okay, this is the back side of the mirror. This is the back side. This is the back side, and it is the front side. This is the front side. It is the front side. So rays are coming clear na, and they are striking on this surface. This surface means this one. Clear na? This surface. This one. This surface. It is the back side. This one. This is the surface. Front surface. It is the front face. It is the front face, and those are the backs. Okay. So first plane, it is concave. It is convex mirror. Now next is, see what is written. This is spherical mirror. This is spherical mirror. So let me complete the topic as per at first. What we have to learn is spherical mirror, concave, convex. So we have to discuss about ray diagrams. Okay, ray diagrams. So total 6 ray diagrams for concave and 2 ray diagrams for convex. Done. So ray diagrams. Next, characteristics of image. Characteristics of the image. Done. Characteristics we discuss. Next one ray diagram, then characteristics, then Then we will discuss about the sign convention. Sign convention. Then we will discuss about sign convention. Sign convention. Sign convention means this sign convention is very much important. This sign convention is very important. Sign convention is very much important. It is very important part. Okay, sign convention. Then mirror formula. Mirror formula and derivation of mirror formula. Okay, derivation of mirror formula. So take your pen, paper, try to understand, note it down. Okay. Ray diagrams, then characteristics of image, sign convention, mirror formula, and derivation of mirror formula. It is our topic. So now some basic you can say basic definitions related to spherical mirror. So basic definitions related to spherical mirror. So now spherical mirror means the spherical mirror either concave or convex. Spherical mirror, concave mirror or convex mirror. Concave mirror or convex mirror. Acha, first sphere. What is sphere? Now this is the sphere. Sir, this is the circle. Yes, this is circle. So if I consider on this 2D plane it is circle. So how to show this is a sphere? Now let me draw three coordinates x, y, z. Now it is a sphere. To see spherical mirror, either concave or convex mirror, it is a part of this sphere. So just consider one hollow sphere. Thus consider football or consider golgappa, puchka, and you are standing at the center of this golgappa inside, okay, or inside the rasgulla. Consider you are an ant and you are standing inside at the center of the rasgulla, okay, at the center. Or just consider one football. So this is the center. Done. Acha. Now I am taking this much part. Okay. So this part I am taking. I am taking this one, this part, this part, this part, this one. Okay. This one, this part, this one, this part. The small part I am taking. So it will be like this. Yes, like this. So this one, so I am taking a small part. This one, this surface, a shell. Okay, football, the shell part, a small part I am taking. So spherical mirrors are the part of some sphere. Okay, which is made up of glass. Is it clear? So spherical mirror is a part of a sphere. It is a part of a sphere. So see, spherical mirror is a part of a sphere. So normal cases for concave we have to show by using this diagram. Okay, this image, and this is for concave and convex. We have to use this type of diagram to show the convex. So moral of the story is what? It is a part of a spherical mirror. So now see, since it is a sphere, so can you tell me what is the name of this distance from center to the surface? It is known as a radius. It is known as radius. So in case of sphere, So we are calling this is radius, the distance with theta. You are giving the name radius. Acha, I am taking this one is a curved part too. This is a curvature, and it is also a part of the sphere. Is it clear? So it has also the radius. ওকে, আরে এটাও তো আমি ওই স্ফিয়ারের থেকে একটা পার্ট নিচ্ছি, স্মল পার্ট। তাহলে এই স্ফিয়ারের যখন রেডিয়াস আছে তখন ওই পার্টটার ওই কার্ভেচারের একটা স্ফিয়ার একটা রেডিয়াস আছে। তো সেটাকে আমরা বলবো ওই রেডিয়ারের রেডিয়াস, এই কার্ভেচারের যে রেডিয়াস তাকে আমরা বলি কি রেডিয়াস অফ curvature. Is the radius of curvature and it is denoted as r. তাহলে আমরা সেটাকে কি বলবো? তো ইন কেস অফ স্ফেরিক্যাল মিরর আমরা রেডিয়াস বলবো না, কি বলবো? রেডিয়াস অফ কার্ভেচার। and this is the center. Okay, this is the center of the sphere. তো এই কার্ভেচারের জন্য আমরা কি বলবো? this is the center of the curvature. Okay, সেটাকে আমরা কি বলবো? center of the curvature. Done. The center sphere, radius. So when we are taking a small part, so that time we write it is radius of curvature. Okay, and it is the center of curvature. Radius of curvature and center of curvature. Radius of curvature and center of curvature. Is it clear? Radius of curvature and center of curvature. Achha. So now let me erase this part, this small part. Let me erase the small part. Achha. So now this is what? This is the spherical mirror, and particularly it is what? Concave mirror. Okay. Acha. Now few terms. So let me write here it is m dash be the concave mirror. Few terms related to spherical mirror means concave mirror or concave mirror. So one point, okay, for consider it is the midpoint you can consider. So midpoint of the mirror, this is called pole of the mirror, and it is denoted as P. So what is pole? Sir, midpoint or the central point of the mirror is known as what? Pole. Okay, so this is pole. Achha, this is bound to curvature. It has one center of curvature. So consider this is the center of curvature, and it is denoted as C. So what is C? C be the center of curvature. What is C? C be the center of curvature. Center of the curvature. Achha. To draw the ray diagrams, we have to draw one reference line. Okay, and which is passes through the center of curvature and the pole of the mirror, and this is known as, this is called principal axis. It is called principal axis. This is called principal axis. So what is principal axis? Principal axis is an imaginary line which is passing through, or which is drawn through the center of curvature at the pole of the mirror. So this one is one imaginary line. Okay. Now next one is what? Next one is another one point we have to discuss about focus. Okay. Another one is focus. Now in normal cases, your parents, your teachers, okay, they are saying concentrate, focus on your studies, focus on your goal. So what do you mean by focus? Focus means ওরা বলতে চাইছে কনসেন্ট্রেট কর, ওকে, কনসেন্ট্রেট কর এই পয়েন্টে, ফোকাস কর পড়াশোনায়, কনসেন্ট্রেট কর পড়াশোনায়, মানে কনসেন্ট্রেট করা মানে কি একই জায়গায় নিজের লক্ষ্যটাকে সেট করা, ফিক্সড করা। You have to fix your target at a single point or on the particular point. Okay, so focus means this is a point where all the reflected rays are meeting. And all the reflected rays means, say I'm taking one particular set of rays which are parallel, so they are meeting at a particular point. Okay, so I can take this type of set of parallel rays. I can take this type of set of parallel rays. I can take this type of set of parallel rays. So it is my choice, and depending on these parallel rays, there is a particular point, clear now, on which all the reflected rays are meeting, and this point is called, or this point is known as, it is known as the focus point, or the focus of the mirror. So I am showing, say this one is, you can say, a pointer, and suppose this is the mirror. So if I see, consider this is the incident ray. So this is the incident ray. Okay, it is the incident ray I am showing. If I use this pointer and here I am showing the incident ray, consider this is the incident ray. So this is the image. If I place one concave mirror here, then you can see. So this is the incident ray, and which is parallel to the principal axis. So consider this is the incident ray which is parallel to the principal axis. I am taking another one ray which is also parallel to the principal axis. So I am taking set of parallel rays, okay, set of rays which are parallel to the principal axis. I am taking this side also. Okay, so all the rays and incident rays, so all of you know, as I said, while marking this one as a ray, it is the principal axis. So what? We can, infinite number of rays are there parallel, so one of the ray may be along the principal axis. Possible, everything is possible, no? Achha. So incident, practically we can observe practically, okay, all the reflected rays, they are meeting, okay, they are meeting on a same point, or at a same point. They are meeting 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 at a same point, and this point is the focus point, and this is known as focus. This is known as focus. It is called focus, or this is known as focus. So what do you mean by focus of a concave mirror? When a set of parallel rays strikes on a concave mirror, after the reflection, all the reflected rays meet at a particular point, or all the reflected rays passes through a single point. একই পয়েন্ট সে সারে রে যাবে, সো একটাই পয়েন্ট থেকে সব রে গুলো যাবে। So all the rays are passing through a single point, common point. So see, they are concentrating at a single point, they converge at a single point. That is why this name is given focus. যত রে আছে সব একই পয়েন্টে কনসেন্ট্রেট করছে, একটাই পয়েন্টে সবাই এসে মিশে যাচ্ছে, মিট করছে। দ্যাটস ওয়াই ইট ইজ নোন অ্যাজ ফোকাস। নাও at the same time, just remember one point, the distance, all the distances are okay, maybe so a few minutes later or after some time we have to use this word, a object distance, then image distance, then focal length, okay. So the object distance notation is what? U. Wait, I'll share the trick also so that you can remember it easily. Image distance, that is V, and focal length F. Clear? Object distance notation U, image distance notation V, focal length F. So it is to focus, and the capital F written for point. To give the name of a point we have to use capital letter. From pure mathematics we know ABC, a triangle, to put capital A, capital B, capital C. So this is the concept. So for that particular point we are using capital A, okay. And here write one point, write one point which is very very important. All the distances are measured from the pole. Write it. This is very very important. All the distances are measured from the pole. All the distances are measured from the pole. All the distances are measured from the pole. যা ডিস্টেন্স মেজার করবো, মেবি অবজেক্ট ডিস্টেন্স, মেবি ইমেজ ডিস্টেন্স, মেবি ফোকাল লেন্থ, তিনটেই আর কিছু না, তিনটেই আমাদের অবজেক্ট ডিস্টেন্স মেজারমেন্ট, ইমেজ ডিস্টেন্স আর ফোকাল লেন্থ, তিনটেই। তাই যাই আমরা মেজার করি না, ডিপেন্ডিং অন দি পজিশন অফ দ্য অবজেক্ট, পজিশন অফ দ্য ইমেজ উইল ডিসাইড। তো যাই আমরা মেজারমেন্ট করি সেটা কি হবে, পোলের রেসপেক্টে, পোল থেকে মেজার করব। দিস ইজ পোল, তো পোল থেকে মেজার করব। সাইন কনভেনশন 1 by 1, at first ray diagram, then 1 by 1. So just you remember all the distances. All the distances means which distances? Object distance, image distance, and focal length. All the distances are measured from the pole. Now you tell me, okay, or maybe focal length, or here is also radius of curvature. Okay, this is also. So everything measurement we have to measure from the pole. And radius of curvature r. So now this is concave meter. Okay, now pole to focus. This is pole. Okay, from here to here, so this distance you have to measure. So now I am using one dotted line to show the scale. Acha, from pole to focus, this one, this distance from here to here, from pole to focus, pole this one. So we can't write this here, that's why I'm drawing a dotted line. I am showing this distance. So pole to focus, it is F. So we can write PF all the distances are measured from pole. PF is focal length. Is it clear? PF is focal length. Next one, PC. We can write PC is radius of curvature. Radius of curvature. At the same time, remember one point, the distance between P to F, the distance between P to F and distance between F to C are same. Okay, for any mirror, maybe concave, maybe convex. So P to F and F to C are same. अच्छा, तो this one PC, so let me write here, right? So PC, okay, is equal, we can write PC is what? PF plus FC. PF plus FC. अच्छा, so PC, what is PC? PC is what? Radius of curvature, and it is denoted as R. We can write R. अच्छा, PC equal PC and PC, P to F and F to C are same. So P to F is small f, focal length. We can write F, and FC to also same, equal to PF. So here again we can write F. So we can write it is what? R is equal 2 times of F. So this is one of the relation, okay, relation between radius of curvature and focal length. Radius of curvature and focal length. Relation between radius of curvature and focal length. So what is the relation? A radius of curvature is equal 2 times of focal length. So we can write the relation. We can write the relation. Relation is what? The radius of curvature R is equal 2 times of F. Okay, or R equal to F. So radius of curvature is 2 times of focal length. Radius of curvature, it is 2 times of focal length. As a one question for 1 mark. Okay, if there is if focal length of a concave mirror or convex mirror given, if f equal 5 centimeter, so what is the radius of curvature? The answer is what? R equal to f. So how to solve? We have to write here R is 2 and f is 5, so this will be 10 centimeter. Is it clear? If R given, how to find f? So we from here we can write f is equal R by 2. If radius of curvature given 15 centimeter, then what is focal length? So 15 by 2, 7.5 centimeter. Okay, clear? अच्छा, लिखो, write it, लिखना. Okay. Now a small concept of magnification. What do you mean by magnification? Magnification means, for example, this is the object, okay, this is the object, it is object, and somehow you are getting, this is the image, this is the image, this is the object and it is the image. So magnification is the ratio of image to the object, means image height to the object height. So magnification is, right now we have to use different formulas also, but right now here magnification means, this is called linear magnification. So this magnification implies, okay, whether, or this magnification provides some information whether the image is smaller than the object or bigger than the object. Okay, so magnification basically provides the size of the object. For example, if it is written magnification is 1, okay, then magnification is 2, magnification is 0.5. So what do you mean by magnification 1, magnification 2, magnification 5 is 0.5? So magnification, this is height of image by height of the object. Now this time, this is the WhatsApp chatting time. Hi, hello. तो hi हो, कैसे हो? Hi हो, hi हो, hi हो, I हो, I हो, hi ho, hi ho, not I ho, hi ho, hi ho. So height of the image to the height of the object. So magnification, it is denoted as m. So we can write magnification m is equal height of the image divided by height of the object. Done. So magnification is what? Height of image to the height of object. And later we will discuss magnification m, that is hi by ho, that is minus v by u, or in terms of u and v, okay, and focal length we can write, okay, we can write it is f by f minus u, okay, or another one formula f minus v by f. So we have one formula, we have two, we have three, we have four. Done. So hi by ho, the height of image by height of object, minus v by u, image distance by object distance. Acha, f, there is focal length, divided by f minus u or f minus v by f. So 1, 2, 3, 4. Right now just concentrate here. M equal hi by ho. M equal hi by ho. Is it clear? Hi by ho. The magnification. Now, what do you mean by magnification 1? So magnification 1 means put m equal 1. So if I put m is equal 1, this is hi by ho. So from here cross multiply, we can write ho is equal hi, means magnification 1 implies object height and image height are same. বুঝা গেল? তো height of the image and height of the object are same. বুঝা গেছে? ঠিক? So now tell me, what do you mean by magnification 2? So magnification 2 implies, see, magnification 2. So magnification 2, the formula is what? 2 is equal height of image by height of object. So cross multiply, we can write height of image is 2 times of height of object. So magnification 2 means the image height, it is 2 times of object height. The object if this is the object and we are getting this is the image. So image height of the image is 2 times of object. If I put magnification 0.5, if I put magnification is 0.5, then it is 0.5 is equal height of image by height of object. Height of image is 0.5 times of height of object. It means height of image is half of height of object. So if magnification is given, then we can write something about the image, whether it is large or small, whether it is big compared to the actual object or it is smaller than the object. বোঝা গেল? তো ম্যাগনিফিকেশন দিয়ে আমরা এটা বলতে পারবো whether ইমেজের সাইজটা অবজেক্টের সাইজের থেকে বড় নাকি ছোট, whether it is quite bigger than the object or smaller than the object. ওকে, নাকি অনেকটা বেশি অনেকটা বড়, then that time we have to use very very greater than, okay, or very very less than, অনেক ছোট বা অনেক বড়র জন্য very very less than or very very greater than. তো done, this is the concept of magnification. Achha, next one, another one concept, it is what? Image. So we have two types of image. One is real, another one is virtual. One is real image, another one is virtual image. So real image means what? Concept of image is, see, when image is what? When reflected ray or refracted rays, they really meet at a point, then the real image. Okay, if they appears to meet, then virtual image means. So just remember, real means when the reflected rays or refracted rays, they really intersecting. Means, for example, if I take, I'll discuss it now. So this is the mirror and principal axis, pole, focus, center of curvature. I am placing the object here. I am taking one ray, this one, another one ray, and again it is reflecting like this. Okay, somehow it is reflecting like this, and I am getting, this is the image point. So see, this is incident ray, it is also incident ray, it is reflecting, so this is the reflected ray. So these reflected ray, that reflected ray, they are exactly meeting at a point. So this type of image is what? When they are really meeting, they really intersect at a point, really. Okay, then it is called real image. And virtual image, in case of normal plane mirror, suppose this is the object, so as we know, we have to draw one ray, this ray, one incident, normal incident case, oblique incident case. So here normal is given, so it will reflect back. Yes, normal incident case we know it is incident, so here is also normal, and angle of incident, angle of reflection are same. So now let me, and for I am taking another one ray, so consider this is another one ray, and it is the normal, angle of incident, angle of reflection are same, so it is coming like this. And if we place our eyes here, then we can see the object where? Here. So as if the rays are coming from this point. Yes, as if the rays are coming from this point. So exactly it is not coming from here, it is just reflecting, but it appears as if the rays are coming from here. So appears to meet. Clear? So this is called virtual image. So they really not intersecting. They are not meeting at a point. Appears to meet. তাহলে মনে হচ্ছে ওরা মিট করছে। তো এই কেসের জন্য আমরা এরকম যদি কিছু পাই যে আমাদের ডটেড লাইন দিয়ে এক্সটেন্ড করে ইমেজ করতে হচ্ছে, দ্যাট টাইম ইউ হ্যাভ টু রাইট ইট ইজ ভার্চুয়াল। It is virtual and real. So another one point, remember this virtual image always erect. Erect means soja. Okay, सीधा. Okay, erect or upright are same. Upright. Erect or upright. अच्छा, real image always inverted. Okay, that is ulto. Okay, or in Hindi this is called ulta image. So consider this is the object. Object, this is the object. This is the object. So a virtual image means same as it is. Okay, virtual to upright. Virtual is upright. This is virtual, and real to inverted. So is for these object, real image is what? This is the real image. So real image is inverted, virtual erect, soja. Okay. Now we'll discuss about the ray diagrams. So today we are discussing only for concave mirror. तो ध्यान से सुनो, ठीक करो शोन, concave mirror part एकदम clear हो जाए. Okay. और एक ऊपर तक numericals maybe class 7, maybe class 8, maybe class 10, 7, 8, 10. तो 6 to 10 কোনো প্রবলেম থাকবে না। তো you can, okay, just you concentrate here. Again, concentrate, focus. All the rays are meeting at a point. Now, next we have to discuss about the ray diagrams. Ray diagrams for concave mirror. So, concave mirror, in case of concave mirror, okay, in case of which mirror? In case of concave mirror, we observed, in case of concave mirror, we observed sometimes we are getting real image, sometimes we are getting virtual. In case of plane mirror, it is always virtual. Okay, not real. I'm taking, if I consider only one mirror, not a combination of mirrors. अगर दो मिरर लोगे तो फिर रियल इमेज बनेगा वर्चुअल ऑब्जेक्ट के लिए. दैट इज अ डिफरेंट कंसेप्ट. तो रियल एंड वर्चुअल. इन केस ऑफ कनकेव, रियल and virtual both we are getting. Sometimes we are getting small sized. Okay, sometimes we are getting magnified. Okay, sometimes we are getting highly magnified. Sometimes we are getting point size. Clear? So sometimes you are getting real, means it is inverted image. So in case of concave mirror, so why it is very much important? See, convex means always, that is our rear view mirror, looking glass. Convex, not concave. Convex. Convex means this type of mirror. Okay, and it is what? It is a view mirror. Which one? Convex. Don't confuse with concave. Convex view mirror. This is a car. ওকে, যেখানে আমরা কার গাড়িতে গাড়ির লুকিং গ্লাস হিসাবে, ক্লিয়ার না, লেফট সাইড রাইট সাইডের অন্য গাড়িগুলোকে দেখার জন্য ইউজ করে থাকি। দ্যাট ইজ ভিউ মিরর। ইট ইজ কনভেক্স অ্যান্ড ইট ইজ অলওয়েজ ভার্চুয়াল অ্যান্ড স্মল। তোমরা গাড়িতে যখন লুকিং গ্লাসে আমরা অন্য অবজেক্টগুলোকে দেখি, সেগুলো তো অবজেক্টের থেকে ছোটই না, একসঙ্গে অনেকগুলো অবজেক্টে দেখতে পাই ওইটুকু স্পেসে। তো এটা সবসময় কি হয়, স্মল 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 সাইজড ইমেজ। ওকে, দ্যাট ইজ কল্ড ডিমিনিশড, স্মলার ডিমিনিশড। আচ্ছা, তো স্মল দ্যাট ইজ অলসো স্মল को that small is also called diminished. Okay, diminished. So here always small and virtual for convex. So today we are going to discuss here further about concave, not convex. So concave. So concave mirror, not convex, concave mirror. Achha. So now let's start. Achha, now question is, sir, why real virtual? The answer is what? Sometimes why say real, why virtual, and how? Answer is depending on the position of the object. It depends on the position of the object. So it depends on the position of the object. It depends on the position of the object. It depends on the position of the object. So for concave mirror, real image, virtual image, small sized, magnified, highly magnified, point sized, diminished. Okay, same sized also. One point is missing. Same sized, same sized also. So see, in case of concave mirror, this concave is very important for us. This concave is very much important because sometimes we are getting same sized image. So in case of concave mirror, same sized, point sized, magnified, highly magnified, small sized, okay, real, virtual. Now one by one we'll discuss. So main point, put it in your mind, it depends on position of the object. It depends on position of the object. Sir, और थोड़ा information से और कुछ information बोलूँ in this. Position means what? Suppose position, तो position of the object, see, so when the object is at infinite distance, মানে অবজেক্টটা অনেকটা দূরে আছে, infinity. Okay, next, when it is near about the center of curvature of the mirror, okay, or সি এর থেকে কিছুটা দূর, সি এর পেছনে, সি এর থেকে কিছুটা দূরে, so then this is called beyond C. So number 1 at infinity, number 2 beyond C, number 3 at C, number 4 between, अरे सर কেমন between, আমার ইচ্ছা short form between, but in your exam don't write B2IN. So I'm writing here between style, हाँ चलता है भाई style. तो between C and F. Number fifth one at F. Write it at F. And sixth one between, again B2IN, P and F. Okay, so at infinity, that time at infinity, beyond C, at C, between C and F, at F, between P and F. Let me draw it, then it will be clear for you. মন দিয়ে পড়াশোনা কর, মন রেখে নিজের কাছে রেখে পড়াশোনা করতে হবে, মন দিয়ে না, মন রেখে পড়াশোনা কর। আচ্ছা তো মন রেখে, নিজের কাছে রেখে পড়াশোনা করতে হবে, মন দিয়ে পড়াশোনা করবে না, মন রেখে পড়াশোনা করবে। আচ্ছা তো let me draw the diagram. So this is this one, concave. So concave, this is the concave. Next we know everything, so just first I'm drawing the principal axis, and this point is what? Pole. Good, it is pole. This one, say this is the focus, and we know P to F and F to C same, so all of you be careful, these two distances are must be same, so this is C. So case one is what? At infinity, মানে অবজেক্টটা যখন অনেক দূরে আছে, जब ऑब्जेक्ट बहुत दूर, infinity, in case of physics infinity is what? Suppose the focal length for this mirror is given 10 centimeter. So for this mirror, infinity 100 meter, infinity. Yes, so is it clear now? So don't think infinity means light year distance. For example, consider it is your school. This is your school, and you are standing in front of the school. So the height of the school is infinity or is infinite compared to your height. Is it clear? This 10 centimeter is infinity for one microorganism, say 10 micrometer. The length of this microorganism is 10 micrometer. So 10 micrometer এর কাছে 10 সেন্টিমিটারটা ইনফিনিটি, এইটুকু অবজেক্টের কাছে এই হাইটটা ইনফিনিটি, 10 সেন্টিমিটারের কাছে 100 মিটারটা ইনফিনিটি। তো দিস ইজ দ্য ইনফিনিটি কনসেপ্ট, মানে অবজেক্টটা যখন অনেক দূরে আছে ইনফিনিটিতে। নেক্সট ইট ইজ বিয়ন্ড সি, মানে সি এর থেকে একটু দূরে। তো দিস ইজ দ্য নোটেশন ফর অবজেক্ট, তো when the object is at beyond C. Next one, so infinity, beyond C. Next I have to shift the object at C. Next one, between C and F. এই সি আর এফ এর মধ্যে যে কোনো একটা পয়েন্টে অবজেক্ট রাখলে সাইজের একটু সামান্য ডিফারেন্ট চেঞ্জ হয়ে থাকে, কিন্তু ওভারঅল ক্যারেক্টারিস্টিকটা সেম। তো বিটুইন সি অ্যান্ড এফ। Next one at F, so at F, and then last one between PF. সেম কনসেপ্ট P2F এর মধ্যে যে কোনো একটা জায়গায় অবজেক্টটাকে রাখলেই আমরা কি দেখি সেম টাইপ অফ নেচার দেখতে পাই। তো এই পয়েন্টের জন্য এই পয়েন্টে যে কোনো পয়েন্টে বিটুইন P অ্যান্ড F রাখো, সেম টাইপ অফ সেম নেচারের ইমেজ তুমি দেখবে। নাও দ্য কোশ্চেন ইজ, স্যার হোয়াট ইজ রে ডায়াগ্রাম and why we have to draw the ray diagram? See, in practically right now though these are not mirrors, okay, yes, here it is written convex mirror. Here focal length is given 20 centimeter. It is concave mirror, okay, concave mirror, convex mirror, so here it is written. So in practical case if we have one object, we have the mirror, okay, we have the mirror, we have the object. So generally we can see the different images, okay. So how to remember this one in future, okay, or 4-5 years later you can easily remember this one, or those who are dealing with the subject they can remember it, but for the beginners, clear na? Right now what is your situation? So right now how to remember this one, how to remember the characteristics of image depending on the position. So one of the way is what? Draw the diagram. Clear na? Draw the diagram and remember, try to write it, okay. Acha, so before going to the ray diagram, before drawing the ray diagrams, before going to the ray diagrams, how to draw it so that we'll get appropriate exact characteristics of the image. How to draw this one, okay. So for this we are following some rules, okay. So if you follow this one, then you can draw the diagram easily and you can remember the characteristics of image, not more than this. So rule 1, rule 2, rule 3 habi jabi, okay. So not like this, those are, you can say those are the process. If you follow it, then you can do it easily. So now we are writing those are as a rules, or you can say this is process, or you have to follow the steps. So whatever you can consider. So to draw the diagrams, draw the ray diagrams, you have to follow 2-3 steps. Step number 1, step one. So this one is what? This is the concave mirror. This is our principal axis. This is the back side of the mirror. This is the pole. It is the center of this is the focus, and it is the center of curvature. It is C, it is F, and it is P. So step 1 or rule 1 or procedure 1. So ray diagram, the first one, it is the important one. Means if you follow this, you can draw the ray diagram easily. If you are able to draw the ray diagram easily, you can write the correct answer about the image, okay. And you can apply this in your real life or in our real life. Is it clear? So now when the incident ray or incident rays are parallel to the principal axis, যখন রেটা প্রিন্সিপাল অ্যাক্সিসের প্যারালাল আসে, when the incident ray is parallel to the principal axis, তাহলে এসে স্ট্রাইক করবে কনকেভ মিররে, so it is striking, okay, or it is falling on a concave mirror. After the reflection, it will passes through the focus, okay. So this is one of the process. You can draw the ray diagram easily. When the incident ray or the incident rays are parallel to the principal axis, after the reflection it will passes through the focus. Point number 1, when the incident ray is parallel to the principal axis, incident ray is parallel to the principal axis, after the reflection it will passes through the focus. This is number one. Number two, the opposite of this one. Again we have a concave mirror. Just draw it. Now, what is the main point you have to remember for ray diagrams? P to F. Once again, P to F. Put it in your mind. P to F. F to C. P to F and F to C are same. So whenever you are using scale, pencil, so take for example you are taking P to F distance is 5 centimeter. So F to C must be 5 centimeter. Then you will get exact ray diagram. Otherwise not. Is it clear? Clear now? So always P to F and F to C distance same need have. For example, you are taking 1.5 centimeter. This side also take 1.5. So means P to C total 5, P to F 1 2.5 2.5, or take 5 centimeter 5 centimeter. Clear? So distance must be same. Next one again principal axis. This is the pole. Again this is a focus and it is center of curvature. So this is F, it is C. Next one, when the rays are passing through the focus, যখন কোনো একটা রে ফোকাস দিয়ে পাস করে বা আমরা যদি ফোকাস দিয়ে কোনো রেকে পাস করাই, after the reflection the ray will be parallel to the principal axis. So after the reflection the ray will be parallel to the principal axis. So it is step 2, or you can say rule 2 or step 2. Like this is one of the step. It is one of the step. I am just marking 1 2 3. There is no proper order to draw. For drawing ray diagrams you can adapt any two, you can draw it. Okay, why 2? It is the minimum. Mi, Ni, okay, Men. Minimum condition. Okay, the minimum case. So to draw the ray diagram, minimum incident rays, the number is what? 2. So minimum you have to choose 2 incident rays. This is the minimum condition. Achha. Another one, this is the again concave mirror. This is the concave mirror. Again principal axis. This is pole. This is focus, and this is center of curvature. Okay. Achha. Be careful. Sometimes for normal incident case we have to consider. Means when, for example, the object is here. Just concentrate here. The object is here, and I have to take normal incident case for ray diagram. I have to take normal incident. Normal incident means how to draw normal ray. Normal is what? Radius. So radius, for example, this is the sphere. So center, and you are standing at the center of a Golgappa. Okay, or you are standing at the center of a football, or you are standing inside a gulab jamun, and you are firing a bullet. Okay, and it is moving upward direction or this direction, but it is a straight path. So this is what? This straight path. It is the normal. It is normal. Clear now? Normal means this one making 90 degree with the surface. So it is normal. So normal incident means it must be collinear. It must be collinear with the center of curvature. It must be collinear with the radius of curvature. So, or it must be passes through the center of curvature. So normal incident, it must be passes through the center of curvature. Okay. So whenever we are taking the ray is passing through the center of curvature. Okay, for example, I am taking one ray and it is passing through the center of curvature. So it will reflect back along the same path. This is the incident direction and it will reflect back along or can say along the same path. So incident path and reflected path are same. Clear? Opposite direction. Incident direction, reflected direction. So it is normal incident case. Is it clear? The first, this is another one step. Step 3. So there is no order. You can write this is step 1, step 2, step 3, or step 1, step 2, step 3, step 1, step 2, step 3. So main you have to any two you have to adapt to draw the ray diagram. But for first 5, this one, it is for these and these also, it is common. Which one is common? These one. Step 1 is common for all the ray diagrams. Okay. For these we have to select for these two diagram either this or this. Basically by using these two steps we can draw the ray diagrams. So now one by one try to draw the ray diagrams. Now step by step, one by one we draw the ray diagrams. Wait 1 minute. Okay. Ray diagram. So first one, when the object is, the position of the object is what? Object is at infinity. Okay. Object is at infinity. अच्छा, तो concave mirror, then concave. Next what you have to do? Principal axis. So this is the principal axis. Now it is pole. Achha. Next consider this one is, this is focus and this is the center of curvature and the object is at infinite. So when the object is at infinity, from infinity rays are what? Parallel. তো যখন অবজেক্টটা ইনফিনিটিতে থাকে, তো ইনফিনিটি থেকে রেজগুলো যখন আসে এগুলো কি হয়? প্যারালাল। তো রেজ আর প্যারালাল টু দি প্রিন্সিপাল অ্যাক্সিস, rays are parallel to the principal axis, rays are parallel to the principal axis. Okay, so those are incident rays. And after the reflection it will passes through the focus. After the reflection all the rays are passing through the focus. So rays are passing through the focus. So those are reflected rays. Reflected rays. So when the object is at infinity, after the reflection all the rays are passing from this point, or they are forming one image here. So this is the image point. So when the object is at infinity, the image is at f. Okay, f. Achha, the rays are meeting, really they are meeting, so it is what? Image is real. Image is real. So the image is at f. When the object is at infinity, image will form at f. So it is forming at f. So what is the position of the image? At f. Achha, real. Then real image always inverted. Okay, real images are inverted. Achha, then you can see real inverted and here they are meeting though. You see point size, so you can write point size image. So it is real, inverted and point size. What is the position of the image? So image is at f. So image will form at f. So what is the image position? What is the image point? F is the image point. What is the position of image? It will form at f. So it is real, inverted, point sized and it will form at f. So when the object is at infinity, the image will form at f. It is real, it is inverted, it is point sized. Achha, now magnification. So magnification it is what? Height of image by height of object. So height of image, this one to point sized, so it is very less than height of object. So magnification m is also very less than 1. Point size means what? It is negligible, no? Tends to 0. The magnification is what? 0 by something. 0 by something or tends to 0. This is very much small. Okay, and this one is, it is big, so it is also very much small. Clear na? Numerator যদি ছোট হয়ে যায় compared to denominator, the value টা অনেক ছোট হবে। এটা যদি অনেক ছোট হয়, এটা অনেকটা ছোট হবে। So m magnification is what? Very less than 1. Done? আচ্ছা, next one is what? Beyond c. Next one is beyond c. Next one is beyond c. Next one is beyond c. So again, this is the, take pen, paper, okay, and then draw the diagrams. Again, what you have to do, you have to draw the principal axis. This is the pole. Consider it is the focus. At the same distance, it is the center of curvature. So this is P. It is focus. It is center of curvature C. Now second case, beyond C. Beyond C means here. This is beyond C. Done. Now we have to apply. You have to use the rule. First one, I am taking one ray which is parallel to the principal axis. Okay, which one is principal axis? This is the principal axis, na? This is the principal axis, and I am taking one ray which is parallel to the principal axis. So when the incident rays are parallel to the principal axis, or the ray is parallel to the principal axis, after the reflection it will passes through the focus. Done. Method number 1 or rule 1 or step 1. Next, minimum condition is what? Sir, minimum condition, you have to take 2 incident rays. Another one I am taking when another one incident ray, when it is passing through the focus, after the reflection it will be parallel to the principal axis. Okay, so it is incident, it is reflected. it is incident, it is reflected. So see, the reflected rays are meeting at this point, means this is the image point. Is it clear? This is the image point. If you take pencil and compass, then you can see this one parallel to the principal axis. So you can see this. So they meet at this point. I am drawing the freehand diagram. You can see exactly like this type of image. So which is, this is the object, this is our object, this is the, and it is the image. It is the image. So you can see height of the image is smaller than height of the object. So magnification M is height of image, high ho. Okay, so it is what, also less than 1. Less than 1 means height of the image is smaller than the object. So we can see it is, we can write it is small sized image. Okay, so small sized image. As a real or virtual, see they are intersecting, so it is real image. So image is real. As a real image, always inverted. Image, it is real image always inverted. As a small sized. Okay, it is real, inverted, small sized. Real, inverted, small sized. Clear? Real, inverted, small size. Position of the image. Position of the image, it is what? Between C and F. So when the position of the object is beyond C, then position of the image is between C and F. So position of the object, this one, and I can write position of the image. Okay, when infinity, then at F. So infinity at F. Position of the image is at F. As beyond C, we are getting it is between F and C. So between F and C. Is it clear? So when object position is beyond C, we are getting image between F and C. When at infinity, we are getting at F. Done? So it is what? This is principal axis, so we know. This is what? Pole. It is focus. It is center of curvature. This is object. We are getting image here. So two cases we are considering: when it is parallel to the principal axis, after the reflection it is passing through the focus. When it is passing through the focus, after the reflection it is parallel to the principal axis, and they are meeting at this point. This is the image point. So this is the image, it is the object. Image height, it is what? Less than the object height. So we are getting magnification, it is what? Hi by ho, high ho, less than 1. So small sized. It is real, they are really intersecting real image is inverted, and position of the image is between F and C. Is it clear? Do it fast. Draw the diagram. Done? Chalo, next one. Third one at C. So let me erase this part, this one. Next one, the object is at C. Object is at C. Done? So now object is at C. object is at C. So again same case, we have to take one incident ray which is parallel to the principal axis. So when the incident ray, it is not parallel, see distance are not same. So use a pencil and compass and try to draw the proper ray diagrams. Okay, this is the focus, this is the center of curvature, and it is pole. And what is and which point we have to remember? P to F and F to C, it will be same. So when ray is parallel to the principal axis, after the reflection it passes through the focus, or it is passing through the focus, passes through the focus. Next one, which is passing through the focus after the reflection, will be parallel to the principal axis, parallel to the principal axis, parallel to the principal axis. Okay, so when it is parallel to the principal axis after the reflection, passes through the focus. When it is passing through the focus after the reflection, it is parallel to the principal axis. This is our principal axis, and now this is the image. So see, when the object is at C, the image position also at C. So when the object at C, image also at C. So C to C, C to C, C to C, C object, C te object, image of form করেছে C te. Okay, done. Clear. Now see, so if you measure this, then you will get HI and HO are same, means height of the image and height of the object are same. So magnification HI by HO is equal 1, means same sized image. Okay, so now the question is, when the same size image will form? If the object is at C, center of curvature object के रखले center of curvature image form होबे আর same size होबे. এটা একদম proper না, এখানে একটু it is not parallel, exact parallel. If you use scale pencil, then you can draw proper parallel, but the image will form at C. So magnification 1 and same size. Okay, now tell me, real or virtual? Real intersecting तो real image, real intersecting तो real image. Okay, अच्छा, real erect or inverted? Inverted image. तो real inverted, upside down. So you can write, say if it is A, it is B, so image is what? It is A dash, B dash is the image. So object height and image height are same, so same size image, real virtual, real virtual, real inverted. So this one is what? It is same size, ignore it. So it is same size, real inverted, position C. So C, object position C, image position also C. So now between C and F. Next diagram is between C and F. Write it fast. Between C and F. Done? Now write. And you have to learn once, না একবারই জীবনে শিখবি, সারা বছর ধরে মনে রাখতে হবে, সারা জীবন মনে থাকবে। अच्छा, now next case is what? Between C and F. So again I have to place one mirror. So this is the mirror. Which mirror? What is the name of this mirror? So one point missing, you write here dash, name of the mirror. Okay, in previous cases also ওই সমস্ত কেসে মিররের নামটা দেওয়ার দরকার। তো মিরর নেম not mandatory but give it. আচ্ছা, this point is pole, so it is P. Consider this point is focus. আচ্ছা, same distance, so is it same? Yes, or nearly. So center of curvature. Next is what? Between C and F. So I am placing the object here between C and F. So same, when the incident ray is parallel to the principal axis, when the incident ray is parallel to the principal axis, after the reflection it passes through the focus. So it is passing through the focus, that is reflected. Next one, next one, exactly. When it is passing through the focus, after the reflection, it is parallel to the principal axis. So see, it is reflected ray, it is incident ray, it is reflected, they are meeting at this point, and this is the image. So say this is AB is the object and this is the A dash, this is the tail. The tail will form here, head is. And now question is, sir, why are you taking from here? Because I am taking the rays from the head and all the rays are hidden rays. I am showing only two, and from here those rays are hidden. So A dash and B dash, this is head B, so B dash is coming here, A tail, so A dash. So height of the image is greater than height of object. So it means magnification, height of image by height of object, okay, which is greater than 1, means image is magnified. Okay, image is magnified. And the position is what? When it is between C and F, then the image position is what? Beyond C. Image position is beyond C. Okay, beyond C. So you are getting beyond C. Real or inverted? Sir, real though. So right, real. Sorry, real or virtual? Real. Inverted or erect? Inverted. So magnified, real, inverted. Magnified means magnification greater than 1. Since height of the image is greater than height of the object, it is real, inverted, position beyond C. Clear? Do it fast. Or two. Right. Write it. Yeah? Next one at F. So this is important, it is also important. It is what? At F. So at F, object, position of the object at F. अच्छा, तो this one is our concave mirror. This is our concave mirror. Next, show the principal axis. So this is the principal axis. Next, identify the pole. This is pole. Sorry. Identify the pole. Next one, we have to identify, you have to mark the focus. So consider it is focus, and same distance, this much distance. So here C. Now it is at F. So consider this is the object. Now rule number 1, when the ray is parallel to the principal axis, after the reflection it is passing through the focus. Okay, it is passing through the focus. Next one, you can take oblique incident case, means angle of incident, angle of reflection are same. Otherwise you can take one ray, normal incident case, normal incident. So you can take one if I take normal, so this is normal incident case. Achha. So we can take one normal incident case C. So though this one is done at, okay, but see, first I am taking one normal ray, okay, normal. So I am taking one ray which is normal, it is quite bent. Okay, I am taking this one, okay, up to this. So this is normal incident. So if I extend it, so as if it is going through C, normal. That time I told you normal incident case, sometimes you have to consider normal incident case. So two methods we have. I am showing the first one. So see, when I am taking normal incident, so it will reflect back, and this is the reflected ray. It is incident, it is reflected ray. So reflected rays are parallel to each other, and parallel rays, they will meet at infinity. So when the object is at F, so they will meet at infinity, because when the rays are coming from infinity, they are meeting at focus. Opposite way, if I diverge this, so when it is going from F, they will reach at infinity. Yes or no? See, when the rays are coming from infinity, they are parallel, okay, and they are meeting after the reflection, they are meeting at focus. And when the object is at focus, so parallel rays, we can getting parallel rays, so parallel rays, they will meet at infinity. It's okay or not? When the rays are coming parallelly, so means what? Object is at infinity. So now here, from this point, we are getting parallel rays, so they will meet at infinity. ইনফিনিটি पे অবজেক্ট था तो প্যারালাল। এখন রেগুলো কি হচ্ছে, এখান থেকে ইনফিনিটি থেকে মিট করবে প্যারালাল, তার মানে কি হবে, অবজেক্ট ইমেজটা কোথায় ফর্ম করবে, ইনফিনিটিতে। প্যারালাল কোথায় মিট করে, ইনফিনিটিতে। তো we can write the image will form at infinity. The image will form at infinity. So image position is what? Infinity. And somehow they are meeting that infinity. Meeting now. So parallel is they are meeting at infinity. So image is what? Real? Meeting too. So the image is real, but it is also inverted. As they are meeting at infinity means here at infinity you can see if I use dotted line and they are meeting at infinity, so you can say height of image is very greater than height of object. So you can write magnification height image by height of object, it is very greater than 1, means we can write highly magnified. We can write highly magnified enlarged image. Okay, so real inverted position is at infinity, highly magnified. There, highly magnified. It's okay now. So this is one process. Another one step, another one in different way we can try it also. So this is one. Another one method we can use. Up to this clear? Up to this okay? Up to this okay? Next we can take oblique incident case. Next we can take oblique incident case. So at this point, which is the normal? This is the normal. Angle of incident and angle of reflection are same. Same. So it will move along this direction. So we can see the reflected rays are also parallel to each other and they will meet at also at infinity. So reflected rays are meeting at infinity. They are parallel to each other. So either previous one, normal incident case, or you take oblique incident case. This is the normal, this is the normal, these angle and these angle are same. It is angle I, it is angle R. Okay, angle I and angle R same. This concept oblique incident, because at this is the incident point, we have to draw the normal, angle I, angle R same. So if you draw, you'll get the parallel line. Okay, take pencil, compass and draw it. So again we are getting parallel lines, so they will meet, these two lines will meet at infinity. At infinity means what? Height of image is what? Very greater than height of object. The magnification high ho, hi by ho, it is very greater than 1. So means it is highly magnified. It is highly magnified. Achha, highly magnified, then real inverted. Now it's okay. Now it's okay. Good. Achha, last one, between P and F, and it is very much important. If you are in class 7 8 standard, then for your exam class 10 mein to they will not give a draw the ray diagram. Maybe it is given for 1 marks, but lens part is important. So if you are in class 7 8 standard, so this diagram is also important. And for class 10, all of you have to draw this one so that you can understand, you can write the significance, you can predict the question. Okay, so next one. Next one between P and F. So consider this is our concave mirror. This is our concave mirror. Now it is the principal axis. Okay, just I am extending this one because there is one reason. I said P because we are drawing the diagram. So this is P. I said consider it is the focus and this is the center of curvature. And this is the center of curvature. Now what is the position of the object between P and F? Between P and F, so I am selecting this is the position of the object. Or I am drawing, consider this is the object. So what is the rule? What is the procedure? last one, between P and F. This is the position of the object. Position of the object. अच्छा, तो if incident ray is parallel, then after the reflection it is passes through the focus. So done. Incident after the reflection it is passing through the focus. Then reflected ray. Now you tell me how to draw the second one. So for these also you can take oblique incident case. So now incident here, angle of incident, angle of reflection are same. Now for this case we are getting diverging ray, So it means if we place our eyes here, then we can see or we can assume the rays are coming from a point which is behind the mirror. So which is reflected ray, this one we have to extend it, and this one is you have to extend the ray, extend this one also. So this is the image point. So if we place our eyes, clear now, we can feel, okay, we can feel the light rays are coming from this point instead of this. Though it is the reflecting ray, this is the object, rays are clear now, moving from this point to that point. After reflection it is reaching here, then here also, but this is the image. Now it is the image. So see, when the reflected or refracted rays appears to meet, then we can see the virtual image. Virtual image. So image is virtual because it is behind the mirror. It is forming behind the mirror. So image is virtual. Second case also you can take normal incident also. You can take normal incident, you can extend, no problem, your choice. But it is oblique incident case is easy, that's why I am taking this one. Okay, so image is virtual, and virtual is erect. Erect means what? ওই যে বলেছিলাম সোজা সিধা. Okay, virtual erect. Or you can write it is upright also. You can write upright also. Then position. What is the position? Behind the mirror. It is behind the mirror. So it is behind the mirror. It is behind the mirror. It is behind the mirror. Okay. And now height of the image is greater than height of the object. So magnification is greater than 1. Means it is virtual but magnified. Virtual and magnified image. So it is magnified. Okay, and this is the reason this mirror, concave mirror is also called dentist mirror. It also called dentist mirror because when the object is, say, consider this is the mirror, and when the mirror is very close to the teeth, clear na? So we can see the large image. Okay, we can see the large image. So when the object is very close to the concave mirror, we can see magnified virtual image, and dentists use this one. That's why this concave mirror is also called dentist mirror. So what is the process? Take parallel, reflected, oblique incident. तो they are not meeting, they are diverging. तो diverging case में क्या करना है? What you have to do? কি করবো আমরা? এটাকে extend করে দেবো. So as if it appears to meet at a point, appears clear as if the rays are coming from a point which is behind the mirror. Now it is, so behind the mirror image is forming here, it is got magnified. So virtual magnified image we are getting. It is magnified, done, erect, virtual. So position of the object, position of the image, done. So in different books it is given in a chart, so no need to memorize, you have to follow the method and you can remember it easily. Okay. Acha. So this part is up to this clear. So practice. Next part we will discuss about the derivation of mirror formula for both for concave and convex, and ray diagrams, two ray diagrams for convex mirror. Okay, and along with this one we will discuss about magnification, and next we will discuss some mathematical problems depending on the mirror formula with sign convention. Okay, we will discuss the next day we will discuss about sign convention, then derivation of mirrors formula, and magnification, that is minus v by u part, then f minus v by f, and f divided by f minus u. So this one we will derive this minus v by u, f minus v by f, or f by f minus u. The magnification in terms of object image distance, object distance, focal length and image distance, focal length and object distance. Next we will discuss magnification, derivation of mirror formula, sign convention, and then mathematical problems. Mathematical questions. Okay, then practice, and that's it.